Alrighty guys, we have done a lot of problems with integration by substitution and we just have 2 more left to go here. Now we've got trig involved in both, and at a quick glance they look very similar, but the way they're approached is actually very different. Alright, so let's just go through how we would do the first one and then see how the second one ends up being a completely different story. And there are multiple ways to do the last one. There's also 2 ways to do this first one. So there's not necessarily one right way here, but you can get to the same final answer, and then identities would allow those answers, even though they look different, to become the same. Alright, so just take a look and let me know if you have any questions. Alright, so this first one, we've got sine of 4x times cosine of 4x dx. Okay, so we need to choose a u so that when we find its derivative, we get the other part of the function. So if I say try u is equal to 4x, the derivative of that would only be 4 dx, which doesn't take care of the fact that I have a product between sine and cosine, so that's actually not really going to get me anywhere. So that's not a good choice for you. All right. So if you start writing that down, sorry, but we're going to get rid of it. All right. The next thing I'm going to choose is going to work, but it's not the only thing that would work. Okay. We know that the derivative of sine is cosine, so let's try doing u is equal to the sine of 4x. Okay. Now the derivative of that technically uses chain rule because we've got a 4x inside of a sine x. Okay, so we change the outside. Sine, the derivative of sine is cosine. The inside stays the same. But now I need to multiply by the derivative of 4x because it was contained inside of the trig function. Okay, so again, this is chain rule. Derivative of 4x is 4 dx. So if I just clean that up a little bit, we usually write our coefficient out in front. Now if I look carefully, we should be able to see some similarities between the original problem, keeping in mind we said that this bad boy right here was u, and if we look at what's left, we had cosine 4x dx, and right here I see cosine 4x dx. So that 4 needs to move to the other side. So we talked about how we can divide it over or multiply by the reciprocal. So dividing out 4 is the same as multiplying by 1/4. Okay, so 1/4 of du can replace that. So now we're ready to do our rewrite. Running out of colors. All right, so I'm going to have a 1/4 and a du to take the place of this piece in red. Okay, and then this is just a u right here. So we have a pretty simple function to find the antiderivative of now. Keep the constant, keep the variable, add to the exponent. Keep in mind that's a 1, so this becomes a 2 over 2 plus c. 1/4 and 1/2 becomes 1/8. And then we have u squared plus c. And our u, we had chosen this right here, sine 4x. And this is as far as you need to go. Remember, there's technically 4 different ways you can write this answer. If you watched one of the previous videos, you would have seen all those different options, okay? So that's one way to do this problem. Now I could have also chosen to do u is equal to cosine of 4x, and this would have worked out. It would have been a very similar answer, and identities would allow us to prove that they are in fact the same thing. But it doesn't matter to me if you can do that identity work. Okay, this is as far as you would need to go. So just keep in mind for this particular problem, you could do cosine 4x. This would have been negative 4 sine 4x. I would have had a negative 1/4 and a u. So I would have gotten a negative 1/8. And then this would have been cosine of 4x instead. And again, you can use identities to show that this and that other expression I just said would be the same. Okay? So there's the final answer there. The question then becomes, well, how is that different from the problem on the other board? Okay, so let's take a look. All right. Here, secant tangent is one of our derivatives that we should know. You should know that if you start with y equals the secant of x, the derivative of that, y prime, is secant x tangent x. Okay, so I could do u is equal to secant of 4x, and it'll probably work out. So that's one way that it'll work. That's what I'm going to show you first. I'm going to show you an alternative. See how clever we can be. All right. So if we go ahead and say u is equal to this right here. This is our u. U is equal to the secant of 4x. All right. This is similar to this was chain rule. This is also going to be a chain rule. Okay. The derivative will be the secant of the inside, the tangent of the same inside, times the derivative of the inside, which is the 4. All right. So again, I'm going to move that coefficient up in front. I'm going to make this du is equal to 4 secant 4x tangent of 4x dx. All right. Which looks very similar to our original problem. All right. See this guy right here? All of this, that's exactly the original integrand. We've never had this happen before where our derivative contained the entire original problem. Okay? So we're going to divide that 4 over like we did on the other one, make that a 1/4. And now we're ready for our rewrite. Okay? So this whole thing in the red box is replaced by the 1/4 du. Okay, so we're not actually going to have a u in our integral setup, which is very different. We haven't had that happen yet. Okay, but the antiderivative of a constant is just a constant times a variable. So this is actually just 1/4 u plus c. This is where I need to pay attention to what my u was, and this is my u right here. So my final answer is 1/4 secant of 4x plus c. So that's one way to get there. A little bit crazy, a little bit different, okay? But now I want to show you what's the alternative. What are some other things we could have done? So questions I commonly get, could I have done u is equal to tangent 4x? And that probably won't work because if I do tangent, the derivative of that is secant squared. There's no secant squared anywhere, so that won't work. But what you can do, some people recognize, oh, I know the antiderivative of secant x tangent x. What if I got rid of the 4 somehow? So that's the alternative that I want to show you, okay? So I'm going to show you how you can still get to this answer, but in a different way. All right? So let's go back to the drawing board. I'm going to leave the final answer here to see if we can figure out how to get there. All right, I'm going to rewrite the original problem. It'll be easier than trying to erase those red lines. All right, so we had the antiderivative of secant 4x tangent 4x dx. All right, so here's our alternative for those of you that are really clever, okay? I could do u is just equal to the 4x right here and right here. What's the derivative of 4x? Okay, so that 4x to the 1, 1 times 4 stays a 4. This would be x to the 0. But we know that x to the 0 is really just 1. So the derivative, for those of you that remember, the derivative of a linear term is just the coefficient out in front, 4 dx. And that's because of this right here, okay? But we're pretty comfortable jumping from there to there at this point, or at least so I'm hoping. So it's okay to make that jump. All right, so now as far as rewriting this goes, I don't have a 4 dx in the original problem, so I'm going to move that 4 over here. So in case you haven't noticed, the 4 keeps jumping ship and moving to the other side every single time. Remember, when you move it over, you're dividing it over or making it into a fraction. Okay, so we are ready to rewrite this. Keep in mind, the secant was not a part of our u, the tangent wasn't, so we're going to have secant tangent still in our antiderivative. So we've got our integral sign, we've got a 1/4 du. The 1/4 du is only replacing the plain old dx. So that's the only thing I've replaced so far. You know what? I think I'm going to need a little bit more writing room. So I'm going to move that du over a little bit. So now I've got secant 4x is u, so I've got secant of u, tangent of also u. There we go. Yep, definitely needed the more space. Okay? And now this is a matter of, do you know your rules? Do you know the antiderivative of secant tangent is actually just secant? Okay? So this becomes 1/4 secant of u plus c. Replace the u with a 4x, and you in fact get to the exact same answer we got from the other way. So both of these problems have at least two ways that they can be done. It's a matter of you figuring out what u is going to work. And keep in mind, sometimes you're going to choose a u, find out it doesn't work. It doesn't mean the problem can't be done. It means try another game plan. All right? Let me know if you have any questions.